Okay, good morning, students. Good morning.
Good morning, ma'am.
Good morning, ma'am.
Yes, good morning, ma'am. Good morning. So, today we'll start with the next topic that is Bitcoin. Okay, about the Bitcoin. So, Bitcoin definition we are going to study today. So, previously we have studied about the various mathematical primitives that are required for securing the Bitcoin network or the blockchain technology. Okay, so now today we will study about this Bitcoin. So this Bitcoin, it can be defined in various ways. That is, majorly we know only that Bitcoin is a currency, right? But Bitcoin is also defined as a protocol, and it is considered as a digital currency and also as a platform, okay, to transfer your money. So protocol, as you know, it's some set of rules, right? So now this we can say it is a combination of peer-to-peer network, the protocols, and the software that helps in the creation of this digital currency. So we can define this in various ways. Similarly, we have different logos also for representing the same. For example, mostly when you see the Bitcoin logo, this will be mostly, you could see that, okay? But this Bitcoin that is with capital B, it is referred to as a Bitcoin protocol. Okay, whereas if it is comes with a small b, if the logo comes with a small b, then that is called as a that is referred to the Bitcoin currency. Okay, but mostly when you see any picture anywhere, it will symbolizes this Bitcoin picture. Okay, so now this in a network. So in a blockchain, in a network, this each node, okay, each node or the each node that is present in the network, they can communicate with each other using this Bitcoin protocol. So now, what is the advantage of this Bitcoin is that after this Bitcoin came into existence, the decentralization was possible. Okay, so before that, this decentralization was not possible this much. But when Bitcoin has been introduced, there is a possibility of decentralization. And another thing is double spending problem. So I think in some of the previous class we have discussed about this double spending problem. When you have the physical currency, there is no problem like this, because you will have a one, for example, if you have a 100 rupees note, you can give it to only one vendor or only one person. You can give it. Okay, so once you transfer that physical note to someone else, that's all, it doesn't belong to you anymore. But when it comes to the digital currency, you will be able to duplicate the thing, and you can spend it twice to two different persons. Okay, so when a user tries to give two different users the same coin, and if it is going to be verified independently, then it will be accepted as valid transaction. But this kind of double spending problem, that was also solved very efficiently using this Bitcoin. Okay, so these are some of the advantages of Bitcoin. So now in the previous classes we have studied a lot about the cryptography concepts, about the symmetric key cryptography and also the public key cryptography. Okay, so we have in public key we have two pair of keys, that is a private key and a public key. And then we have studied about elliptic curve cryptography and so on. So now how this all these were applicable here in this Bitcoin. So we have studied about the SHA-256 algorithm. We have studied about the hashing, okay, what are all the various hashing algorithms available, everything we have studied earlier. So now how this is used here in the Bitcoin. So elliptic curve cryptography, this method is going to be used to generate the public and private key pairs. So I hope you remember the elliptic curve that we have seen as a video, as well as the PPT we have discussed. So it consists of a pair of points, right? So x coordinate and a y coordinate will be there. So while you are connecting that, you'll be getting several different points in the curve. So this elliptic curve cryptography is used to generate the public as well as the private key pair in this Bitcoin network. So how the Bitcoin address is calculated. So now we have the public and private key pair generated using the elliptic curve cryptography. So maybe this elliptic curve cryptography, how they are generating that public and private key, maybe one more time I'll show you with different explanation. So now how Bitcoin address is created from that. So you have a public key for a corresponding private key. Okay. Now this public key, it is going to be hashed twice. Okay. And as you know, there are several hashing algorithms. So what we are going to do is, you can see in this picture, we have a public key. Okay. So this public key is generated using the elliptic curve cryptography method. So now initially the public key is going through the SHA-256 algorithm. Okay, the first time it is hashed. So, and this next time it is hashed using the RIPE-MD 160 hash algorithm. Okay, so these two are used in the process of creating a Bitcoin. So after this public key is has gone through these two hashing algorithms, it creates a hash value. Okay, so it's going to create a fixed value of a public key hash value. Okay, that is 160 bits. So now after this resultant 160 bit hash, it is going to again go through some process, that is that we call it as a base 58 check encoding scheme. Okay, base 58 check encoding scheme. So so actually this is a separate process which we are not going to discuss. If you want, when time permits, I'll show you that. So this 160-bit hash, it is going to be prefixed with some version number. Okay, it is going to have a version number starting with this hexadecimal value 0x00. Okay, so a hash a prefix. A version number is prefixed to that hash value, and also then it goes through the base 58 check encoding scheme. Okay, so by this finally you will be getting a Bitcoin address. So this Bitcoin address, we are going to use it for our transactions to transaction between the other persons. So why we are going for this base 58 check encoding scheme is that, so now there may be confusion with the characters and digits like 0 O and then 1 and I, okay, or 1 and L. So to avoid the confusion between these characters, we are going for this encoding scheme. Okay, second. Okay, I hope you will be able to see this. Yes, right? Okay, I'll show you this base 58 check encoding also. So this here we have seen that after getting the hash value for this by applying the hash algorithm twice. Okay, one hash algorithm is SHA-256 and another one is RIPE MD160. So after this, we'll be getting a public key hash value which is of 160 bits. So to this resultant 160 bits will be prefixing with a version number that is 0x00, and then it will be encoded with the base 58 check encoding. So what happens is in the first step you add the version, okay, and then this version prefix plus payload is nothing but the hash value that we have got, okay, that is that 160 bit. So again this will go through the SHA-256 algorithm twice, okay, it will apply the SHA-256 twice, and the resultant value will be a 32 byte value. Okay, a resultant will be 32 byte. You can see here. Okay, checksum is calculated here. Okay, so you can see the prefix plus data, that is the version number and the hash value. Okay, so for that we are applying the hash function SHA-256 twice, SHA-256 of this one, then the resultant is again passed through next time again the SHA-256 algorithm. The result will be a 32 byte value, and in that the first 4 bytes will be taken as a checksum value, okay, and this will be so this will be again added with that previous thing, okay. So now we'll be having the version, that hash value, that is payload, and then the 4 bytes that we have got after hashing this value twice, okay. So now this is the now this will go through a encoding scheme called base 58 encode, okay. So now why we are using that is to avoid the confusions that are happening because of this the 0 and O and then L and I, okay. So the or 1 and L, so these kind of confusions can be avoided using this encoding scheme. So this will basically, it will take the byte arrays, binary byte arrays, and convert them into a human readable string. Okay, it will be going to be a human readable string, because if it is always going to be a hexadecimal values, will not be able to read that, but it's going to be a human readable string. And then the so finally the string will be composed of 58 alphanumeric symbols, okay. So that is why this base 58 check encoded payload we are getting here. And so normally a Bitcoin address will look something like this, okay, a combination of numbers, alphanumeric, okay, numbers as well as the characters from the alphabet. And for each Bitcoin address, there will be a QR code also, okay. So you know very well what a QR code is. So for easy sharing, this QR code can also be used. So usually this Bitcoin address will be of length 26 to 35 characters, okay. So it is not a fixed one, it may be 26 to 35 characters long, and usually it begins with either the digit 1 or digit 3. You can see here this given example, the Bitcoin address starts with digit 1, or it may start with digit 3, okay. So that is the standard. So now there are two types of addresses. One is called as P2P KH. Okay, P2P KH. That means pay to pub key hash. Okay, pay to pub key hash. So the meaning of that is, so we know the publicly available, the public address of the recipient. Okay, so you want to send you want to make a transaction between to a person. Okay, so his public address you will be knowing. And if you are going to send the transaction, or if you are going to pay to that public key directly, that is the thing that is earlier available. Okay, earlier it was simply pay to public key, but then this P2P KH means that public key is hashed. Okay, the hash of the public key of the recipient. Okay, so to that we are going to pay. So that is why it is P2P KH. And another type of address is P2SH, that is pay to script hash. Okay, pay to script hash. So when this is, so here this P2P KH address will start with the value 1, and P2SH type, it starts with the starts with the value 3. Okay. Now, when this P2SH script function will be used is that it will be mostly used for the multi-sig addresses. What is multi-sig is multiple signatures. Okay, so that is to authorize a particular transaction, we require more than 2 or more number of person to give their digital signatures. See, for example, you might have access to your locker, okay, in the banks. So usually the bank will give one key to us, and they will have another key with them. Okay, so if you want to access that locker, both the keys has to be both the keys has to be used to open that locker. Okay, so in the same way, when you want to make a transaction, if 2 or more number of digital signatures are required to authorize the transaction, then that is called as multi-sig addresses. Okay, so only in that kind of thing this P2SH script addresses are used. Okay, these P2SH type addresses. And so earlier it was, as I said, this pay to pub key was used, and still now it is used, but now it is superseded by this P2P KH. Okay, the hash of the thing. So now, as this Bitcoin address is created, okay, so I hope you understand the creation of the Bitcoin address. So from where it starts, first it starts with the creation of the public private key pair. Okay, so that is done using the elliptic curve cryptography. So once the public key and private key are generated, so you know that the private key will be generated using a it will be generated randomly, and from private key public key will be generated, and from this public key, after it passes through 2 hash algorithms, okay, it produces a hash value of size 160 bits, and then it goes through the some base 58 encoding scheme, and finally your Bitcoin address will be generated. Okay, and this addresses, it should not be used more than once. Okay, so for every transaction you need to create a new address. So a new Bitcoin address. Okay, so the Bitcoin address has to be okay, the Bitcoin address has to be created or generated every time you are making a transaction. Okay, Srikanth Naik, have you joined now only? Srikanth? What, ma?
I'm having network issue, ma'am. Just now I got members, so I joined just now.
Okay.
Okay.
Okay, so this addresses, it has to be, it should not be used more than once. So every time you do a transaction, a new Bitcoin address can be created. And so as you are avoiding this reuse of this address, this will cut down the problem of these problem related to security and other things can be resolved very easily. Okay, so the privacy and security issues can be easily avoided by not reusing the address. So public keys in Bitcoin. So how this public keys are helpful in Bitcoin? So as we know, the public keys are generated from the private keys, and Bitcoin uses the ECC, the elliptic curve cryptography based on the SECP 256K1 standard. I hope you remember. We saw the video, and we have looked at how this elliptic curve cryptography works and what is the standard that is used. So this is the standard that is used to create the Bitcoin. So now, first initially a private key is selected at random, and that will be of length 256 bit. Okay, so this it can be generated from a you can see here. Okay, I'll show you there. First, we'll look into the public keys. So now the public keys will be generated from the private key. Okay. Now this public key, it can be either in a uncompressed format or compressed format. So what is this uncompressed and compressed format? The thing is, here you can we are seeing that from the elliptic curve cryptography we are taking the private and public key pair. So what is that elliptic curve cryptography? It is made up of different coordinates. Okay, the points are joined together to make the curve. So you will be having an x and y coordinate. So in the previous class we have seen some of the examples. So we have some function like y square equal to something. So when you apply x values, different x values for that, you will be able to find the y value. So that x and y value marks a point on the graph. So similarly, you keep on marking the points and you are able to get a curve in the graph. Okay, so and all these elliptic curves are symmetric in nature about the x-axis. So above the x-axis and below the x-axis, the shape of the curve will be similar. Okay, so that is symmetric in nature. So now, since we are having this x and y coordinates on the elliptic curve, this public keys are basically this x and y coordinates. Okay, that is what we call it as the public key. And this can be represented either in an uncompressed or compressed format. So what is the compressed version and uncompressed version is that in a compressed version, the only the x part will be included. That is, only the x coordinate will be included. Okay, because if you know the value of x, you will be able to calculate y, right? So for example, if y square equal to x cube plus 3, then if you know the value of x, you will be able to find out what is y. So here in the compressed version, to reduce the size of the to reduce the length of the key size, the only the x part, that is the x coordinate alone, is used. Okay, so that is the compressed version of public keys. So the compressed public key will be 33 bytes long, and the uncompressed format will be 65 bytes long. And this x and y coordinates both will be of size 32 bits. Okay, both will be 32 bits in length. So now usually from after this Bitcoin Core Client 0.6 version, only the compressed keys are used as the standard one. Okay, but still uncompressed is also there, but initially they were used, but now the compressed keys become the standard for this Bitcoin, for this public keys. Okay. So the same thing, the only thing is the prefixes that are used. So here we can identify the key based on the various prefix. If it is an uncompressed public key, then it will use the prefixes 0x04. Okay. And if it is compressed public key, and if the y32 bit of that 32-bit part of the y coordinate is odd number, okay, if it is an odd number, then the version prefix 0x03 is used. And if it is a even number, okay, if the y part is even number, then the public key will start with 0x02. Okay, so by this we'll be able to identify whether it is an uncompressed public key or compressed public key, and if it is compressed, whether the 32-bit part of the y coordinate is a odd number or a even number. Okay. So this is about ECC. Then the private keys in Bitcoin. So the private key first. So we have already seen in the previous class, we cannot generate the private key from the Bitcoin address. First, you cannot generate a Bitcoin address on your own as you wish, and then you cannot generate the private key. Okay, that is not possible. First, you have to randomly select a private key. From that, you have to generate the public key, and from that only you will be able to generate the Bitcoin address. Okay, so the process cannot be reversed. You cannot simply take some Bitcoin address and you can go through this. Okay, and so this private keys, initially it is chosen in the range specified by this standard. Okay, SECP 256K1 ECDSA recommendation. ECDSA is the elliptic curve digital signature algorithm. And so this 256 number, it can be taken at random between these two numbers. Okay, 0x12. This is the last number, which could be the 256 bit maximum number. Okay, so now any number that is chosen range can be a valid private key. And this private keys, this is going to be encoded using a wallet import format. See, we should make sure that the private keys has to be maintained secretly and very confidentially, and it has to be handled by only that particular person. Okay, it should not be shared with anyone else. So it is encoded using a wallet import format, so that it will be easier for the user to make the transaction by just simply copying and using that address. Okay, so for any digital signature, you need to have the private key. So it is encoded using a wallet import format, that is WIF. And then this can be, so on both the ways it can be reversed. The private key can be converted into a wallet import format, as well as this wallet import format can be converted into a private key. Okay, so both are possible. And there is one more format, that is mini private key format. Okay, mini private key format. This is sometimes used to encode the key in under 30 characters. Okay, so here it's helpful to reduce the size of the key. So under 30 characters, it is able to do that. And the Bitcore client also allows the encryption of the wallet that contains the private keys. So here we have seen that these private key are encoded in a particular wallet format, and that again can be encrypted to have the private key very securely. Okay. And this Bitcoin currency units, this is important. You should know what are all the currencies, what are all the denominations available. Okay, like how in our Indian rupees we have a 10 rupees note, then 100 rupees, 50 rupees, 20 rupees, 50 rupees, 100 rupees, 200 rupees. Okay, so these are all different denominations. In the same way, in Bitcoin also we have several currency units. So in that, the smallest Bitcoin denomination is called as the Satoshi. Okay, it is named after that person who has invented this. So Satoshi is the smallest Bitcoin denomination. And for each of these denominations, we have a common name or a familiar name. Okay, we have a common name or a familiar name that is also available, and these are the abbreviations for the for each of the denomination. And here it is the value is given in Bitcoin. So Bitcoin is represented using the abbreviation BTC. Okay, now you can see Satoshi, it is equivalent to 0.0000001. Okay, so that is the smallest amount, that is the smallest denomination. And then comes the microbit, then millibit. So you can see what is the equivalent value of Bitcoin: millibit, centibit, decibit, then Bitcoin. Okay, so before Bitcoin, like how we have rupees, 1 rupees, and then you will earlier we had the coins, but now we are not using 50 paise and all those things. Okay, so but we similarly here Bitcoin is the value is 1, but before that we have a very smaller values too, which can be converted into the Bitcoins. So then decabit, that is 10, that is equivalent to 10 Bitcoins. And hectobit, hectobit is equivalent to 100 Bitcoin. Then kilobit, as always the name says, kilo, 1000 Bitcoin. Megabit, it is 10 lakh Bitcoins. Okay, so this is the various denominations that are used for Bitcoin, and each Bitcoin is each denomination is having an equivalent value for the Bitcoin. And these are all the common names or the familiar names that are used for each of these denomination. So this microbit, Satoshi is always called as Satoshi, and microbit is also called as microbitcoin, millibitcoin, centibitcoin, decibitcoin. Okay, actually there are some other names are also there based on some person names, so that also I'll share if I find it. Then finally, there is another thing called as vanity addresses. As this Bitcoin addresses are based on this base 58 encoding, we'll be able to generate the addresses that are in the human readable format. Okay, so the Bitcoin address we have seen, it's all alphanumeric characters. So you'll be able to read those, read that thing. Okay. So this is all about this Bitcoin definition. So in the next class, we will start with the transactions. Okay, how this Bitcoin transactions, what is a transaction, and how this transaction happens, and how the money is sent and received. All these things we will study in the next class. Okay. I have uploaded the marks in the EduServe, so kindly check that. And kindly give your attendance, ma. Pragna,
Present, ma'am.
Neela Sumant, Neela Sumant, Jomin Jose, Jomin Jose, Manoj Preetham, Manoj Preetham, Jerome. I think finally.
I am Neela Suman present.
Where have you gone? Did you listen the class, Neela Sumant?
Yes, ma'am.
Jerome Andrew. Okay, Nelson Darius. Nelson Darius. Gemini Annie Verghese. Sheshandri. Annie Cruz.
Present, ma'am.
Madhumita. Final years, do they have the placements anything today?
Yes, ma'am. Level 2 of
Okay, that's why many are absent. Okay, I'll check that. Madhumita.
Is attending placement.
Okay. Okay, Mukesh is there. Then Naveen Kumar.
Yes, ma'am.
Satish Kumar.
Ma'am, Satish also at placement.
Okay, okay. Preetham.
Present, ma'am.
Jeffrey Jabastin.
Present, ma'am.
Benzam Raj.
Present, ma'am.
Angeline Subhagar. Angeline. Ujjal.
Present, ma'am.
Lasvita.
present, ma'am.
Joel Sam.
Present, ma'am.
Steve Abraham.
Present, ma'am.
Aditya.
Present, ma'am.
Bevin Jeff.
Present, ma'am.
Soumya. Soumya. Sneha.
Present, ma'am.
Joseph Rajan.
Present, ma'am.
Karen Beulah.
Excuse me, ma'am. Roll number 8, present, ma'am.
Yeah, Angeline, where have you gone?
My mic was not working, ma'am, so I went out and came back.
Okay.
Andri, 212.
Sheshandri, why you are coming now?
Ma'am, the similar issue, network issue. I was trying to speak, but then
Okay, okay. Christo Saharia.
Present, ma'am.
Divina. Alex Kuriakos.
Present, ma'am.
Bharat.
Present, ma'am.
Ashish Kumar. Okay. Emmanuel Raja. Emmanuel
Present,
Raja. Jabez Samuel.
Present, ma'am.
Sam Jonathan.
Present, ma'am.
Jib is present, ma'am.
Yeah, yeah.
Okay.
Vigneshwar.
Present, ma'am.
Chinmonlal.
Yes, ma'am.
Letitia Miraculin.
Present, ma'am.
Christina Sherin.
Present, ma'am.
Ashley John.
Present, ma'am.
Hayden Rex.
Yes, ma'am.
Sriram Prasad.
Present, ma'am.
Jemima Elizabeth.
Present, ma'am.
Harsha Anna.
Yes, ma'am.
Rajat Nair.
Present, ma'am.
Rishabh Nair. Manoj Abraham.
Present, ma'am.
Bibia Susan.
Present, ma'am.
GB Thomas.
Present, ma'am.
Selvam Abhisha.
yes, ma'am.
Abhilash. Abhilash. Abhilash, are you there? Okay, I think he's trying to. Okay. Don Milton.
Present, ma'am.
Genovin.
Present, ma'am.
Darwin.
चप्पू के पापा मत
Present, ma'am.
मत पुश कर छोड़ छोड़ अंदर पकड़ ले, वहाँ पीछे से वो आएगा, ओमन आएगा, ओमन आएगा, ओमन
1064.
डाउन.
Mute your mic. Darwin.
Present, ma'am.
Lamek.
Present, ma'am.
Maria Santosh.
Yes, ma'am.
Sasidhar Reddy.
Present, ma'am.
Austin.
Present, ma'am.
Kambam Sanjay.
Present, ma'am.
Kevin Paulson.
Present, ma'am.
Sri Sai Rahul Reddy.
Yes, ma'am.
Kavin.
Present, ma'am.
Singham Shetty Johnson.
Present, ma'am.
Lewis Kishore. Lewis Kishore. Sai Srijan.
Present, ma'am.
Sriram.
Present, ma'am.
Okay, thank you, students. You can leave the
Ma'am, you didn't call me, ma'am. Srikant, ma'am.
What is your number?
1257, ma'am.
1257.
Yes, ma'am.
Ma'am,
But it is not showing. 11? Yeah, I have marked you present.
ma'am, 1019, ma'am, is it not present?
1019. Soumya, no, you have not responded.
Ma'am, my mic wasn't working, I guess, so I joined in phone again.
Okay.
Excuse me, ma'am.
Yes, ma'am.
Ma'am, can you upload the teaching plan for?
Okay, ma. Is it not there already?
No, ma'am.
Okay, I'll put it there.
Thank you, ma'am.
Yeah.
Ma'am, 1257, ma'am.
Yeah, Srikanth, your number is not showing in EduServe.
Ma'am,
Yes, ma'am.
What, ma? Divina, where have you gone?
Ma'am, I got some network lag, ma'am.
Okay, ma.
Thank you.
Jomin Jose, are you there? Srikanth, you have joined now only or you are there already?
Already I was there, ma'am.
Okay, but now your name is not showing up in EduServe. Why?
Daily I'm getting, ma'am, attendance.
Yeah,
Today only.
but in EduServe now it is not showing. Your name is not showing. I don't know.
Don't know, ma'am.
Okay, check with your mentor also. Okay.
Okay, ma'am.
Is there any problem? Okay.
Okay, ma'am.